Good morning, students. Our today's topic in the subject of mathematics D3 O-level class is matrices. And the first thing that we are going to read in matrices is order of a matrix. So very important things these are. You have to be very focused. Order of a matrix. So listen, in a matrix, these elements are called, for example, here are some elements. These elements are called rows, and these elements are called columns. So the horizontal line is called rows, and vertical lines are called columns. So the order of the matrix is, first you have to write the number of the rows. So in this matrix, you can see there are 2 rows and there are 2 columns. So the order of the matrix is 2 by 2. There are 2 methods to write the order of the matrix. One is this method, and second you can write like this. First you have to write the rows, then you will write by, and then columns. Okay, I'm going to write an other matrix. For example, 2, 5, 1, 3, and 0, -6. Okay, if we are required to find the order of the this matrix, so look now, there are 1, 2, and 3 rows. So 3, because rows will be written first, and then there are 2 columns. So into 2. So the order of the matrix is 2. Okay, look now, here is an other matrix. For example, 1, 5, -3, 0, 6, 0. So if we are required to find the order of this matrix, the number of the rows are 2. So 2 by, and there are 3 columns. So 2 by 3 is the order of this matrix. The next thing that we are going to read in the topic is row matrix. So concentrate yourself. A matrix with exactly one row is called a row matrix. For example, here are some examples. So 0, 1, you can see only one row. Another example is 1, 5, -3. And other example may be 1, 2, 5, -4. So if you can see all these 3 examples, so the matrix is having one row only. So that's why this is called a row matrix. The next thing in the topic is column matrix. So a matrix with exactly one column is called a column matrix. For example, here you can see the examples. So for example, 1, 2, if you can see only one column is there. And other example may be 5, 0, -3. You can see again only one column. And other example may be 2, -5, 0, 6. So in this matrix, you can see again one column. So a matrix with exactly one column is called a column matrix, and examples are here. The next thing that we are going to read in the topic of the square matrix is in the topic of matrices is square matrix. So square matrix is a matrix in which number of rows is equal to the number of columns. So this is a matrix in which number of rows is equal to number of columns. So the examples may be 2, 0, 1, minus 5. You can see 2 rows, 2 columns. So this is a square matrix. And other example may be 1, 0, 5, 2, minus 3, 7, and 7, 5, 4. So look now, you can see there are 3 rows and 3 columns. So this is a matrix. Square matrix is a matrix in which the number of the rows are equal to the number of the columns. And here are the examples. Next type which we are going to read in the matrices is a diagonal matrix. So look now, the diagonal matrix is a matrix in which the entries other than the leading diagonal are 0. Examples are here, for example 4, 0 and 0, 5. So you can see the leading diagonal is non-zero and other than the entries are all 0. For example, here is an other example. So 1, 0, 0, 0, 5, 0 and 0, 0, minus 3. So in this diagonal in this matrix you can see the leading diagonal are non-zero and other than the entries are 0. So these kind of the matrices are called diagonal matrix. Another type almost same is called identity matrix. Identity matrix is a matrix that is almost the diagonal matrix, but the leading diagonal entries are 1, 1. For example, this is a matrix in which you can see the leading diagonals entries are 1, 1 and other than the all entries are 0, 0. And other example may be 1, 0, 0, 0, 1, 0 and 0, 0, 1. So you can see the leading diagonals entries are 1, 1. So this is conditional in identity matrix and all the other entries are 0. So identity and diagonal matrix are different in a way that in identity matrix the leading diagonals entries are 1, 1 and except that all entries are 0. But in diagonal matrix the leading diagonal entries are other than 1, 1 but they are non-zero and all the other entries are 0. So these are the concepts. The next type in the topic of matrices is zero matrix, that is also called null matrix. So these are two names of the same matrix. So zero matrix or null matrix is a matrix in which all the entries are 0. For example, examples are here. So you can see all the entries in this matrix are 0. Another example may be, so this is a matrix in which all the entries are 0. That matrix is called null matrix or zero matrix. So these are the examples of null matrix or zero matrix. Next type is equal matrices. So for equal matrices, there are two conditions. Order should be same and number 2, elements should be same. For example, here are the examples. So maybe 1, 5, 2 and minus 3. So if you look at this matrix, here I'm writing an other matrix. So you can see 4 minus 3, 2 plus 3, 7 minus 5 and minus 4 plus 1. So in these two matrices you can see the order is same because first matrix is having 2 by 2 order and the second matrix is also having 2 by 2 order. So order is same. And second, The first element is 1, so if you solve it, it will become 1. Here is 5, so if you solve it, this is 5. Here is 2, if you solve it, this will be 2. And this is minus 3, so if you solve it, this is minus 3. So you can see the elements are same and the order is same, so that's why these are called equal matrices. So this is the example of the equal matrices. Here is a question. The statement is if A is 20, B, C 16 and B is 4A, A plus 3, D minus 4 and D, and A is equal to B. Find A, B and D. So it is given that the matrices are equal. So it means if the matrices are equal, their respective elements will be equal. So this is the condition for equal matrices. So it means 20 will be equal to 4A. And from here you can see A will be equal to 20 by 4. And 4 ones are 4, 4 fives are 20. So A is equal to 5. Next, you can see B is equal to second element should be equal to second. So B is equal to A plus 3. Because A is now 5, so 5 will be put in place of A, plus 3 is same remaining there. So B is equal to 8. So B is also done. So now first we are comparing the last element, that is fourth element in both matrices. 16 is equal to D. So from here you can see D is equal to 16. So this is another alphabet that is done. So, and the last one is C. C is also required. So from here you can see C is equal to D minus 4. And D's value is 16. Minus 4 is still there. And 16 minus 4 will be 12. So C's answer is 12. So these are the answers. Here is another question. So concentrate yourself. If A is equal to 2, 3, 5, 7, B is equal to this, C is equal to this, and D is equal to this. If you can see, first two matrices are having the same order, but then different orders. Because the order of this matrix is first rows, then columns, so 2 by 2. Order of this matrix is also 2 by 2. Order of this matrix is 2 by 3. Order of this matrix is 3 by 2. So, requirement is evaluate where possible. So, listen very carefully. For adding and subtracting the matrices, order should be same. If order is same, then we can add and subtract the matrices. If order is different, we cannot add and subtract. So look now, A plus B. So because the order of these two matrices are same, so we can add them. So the method will be first A is written. So 2, 3, 5, 7 will be written first. Then plus sign is there. And then B. B is minus 3, 5. And minus 6, 1. So the very simple method is simple algebraic rules will be applied. So simply you will add the respective elements. So first will be added in the first, second in the second, third in the third, and fourth in the fourth. So again the plus minus rules will be applied. So you know plus when plus plus are multiplied, answer is plus. But when plus minus or minus plus are multiplied, the answer is minus. So look now, 2 plus minus 3. So plus minus will become minus, minus. So 2 minus 3. Then second element 3 plus 5. Then third element 5 plus minus will become minus. So 5 minus 6. And finally 7 plus 1. And in the last step, we will solve it now. 2 minus 3 will be minus 1. 3 plus 5 will become 8. 5 minus 6 will become minus 1. And 7 plus 1 will become 8. So this is the answer. Okay, in second part, if you see, D is 3 by 2 order matrix, and C is 2 by 3 order matrix. So because order is different, so this is not possible. Okay, in third part, B and A are required to be subtracted. So because order is same, so because order is 2 by 2 and its order is also 2 by 2, so because order is same, that's why we can solve it. So first B will be written, that is minus 3 5 and minus 6 1. This minus sign is still there, and A is 2 3 5 7. So simple rules of subtraction will be applied. So respective elements will be subtracted. So look now, minus 3 minus 2. Then second element 5 minus 3. Then third element minus 6 minus 5. And finally the last element 1 minus 7. And now we will solve the values. Minus 3 minus 2 will be minus 5. 5 minus 3 will be 2. Minus 6 minus 5 will be minus 11. And 1 minus 7 will be minus 6. So this is the answer of this metric, this expression. Okay, finally we are required to find 0 plus D. Actually, zero matrix. So zero matrix is a matrix in which all the elements are zero. So we are required to add it with D. So we can make zero matrix of the same order. So look now, we require 3 by 2 matrix. So for example, zero matrix is 0 0. And this is another simple thing, very simple thing, that is algebraic rule. When 0 is added with anything, answer is the same thing, that is adding with the 0, or subtracted. When 0 is subtracted from the something, answer is same. For example, 0 plus 5 is 5, or 5 minus 0 is 5. So look now, when 0 is going to be added with D, so answer will be D. And D matrix is this one, 3 7, 9 minus 8, and 4 2. So this is the answer of this matrix. The next thing that we are going to read in the topic of matrices is multiplication of a matrix by a real number. So this is again very simple. The simple rules of algebra will be applied. So look now, we are required, if A is equal to this matrix and B is equal to this matrix, evaluate 3A plus 2B. So look now, 3A. So first we will write 3, then A matrix, that is 3 minus 2, 1 4, plus 2 is there, and then B matrix, that is minus 1 3 and 6 minus 5. Likewise, simple algebraic multiplication will be done. So look now, 3 will go inside the matrix. 3 will be multiplied with each and every element of this matrix. So look now, 3 3s are 9, 3 minus 2s are minus 6, 3 1s are 3, and 3 4s are 12. Okay, this plus sign is there. Now 2 is going to be multiplied inside this matrix, so it will be multiplied with every element. So 2 minus 1s are minus 2, 2 3s are 6, 2 6 are 12, and 2 minus 5s are minus 10. Okay, now we will add, the respective elements will be added. So again, plus minus will be minus. So look now, 9 plus minus will be minus. So 9 minus 2. Then minus 6 plus 6. Then 3 plus 12. And then 12 plus minus will be minus. So 12 minus 10. So at this step, now we will do the last step. that is simplification. 9 minus 2 will be 7. Minus 6 plus 6 will be cancelled, so the element will be 0. 3 plus 12 will be 15, and 12 minus 10 will be 2. So this is the answer of this expression. Likewise, here is another matrix expression. So look now, 4 is written first, so that will be written as it is. Then b is minus 1, 3, 6 minus 5. Then minus 2 is there, and after that a is there. So a is 3 minus 2, and 1, 4. So likewise, the elements outside the matrix will be multiplied inside first. So look now, 4 is going to be multiplied with each and every element of the matrix. So 4 minus 1s are minus 4, 4 3s are 12, 4 6 are 24, and 4 minus 5s are minus 20. This minus sign is still there, and this 2 is going to be multiplied inside the matrix. So 2 3s are 6, 2 minus 2s are minus 4, 2 1s are 2, and 2 4s are 8. Now again, simple algebraic method will be applied, algebraic rule will be applied. So minus 4 minus 6. So look now, minus 4 minus 6. Then 12 minus minus will become, so 12 plus 4. Then 24 minus 2. And finally minus 20 minus 8. Bracket close. Okay, now the final step will be done, that is simplification. So minus 4 minus 6 will be minus 10. 12 plus 4 is 16. 24 minus 2 is 22. And minus 20 minus 8 will be minus 28. So this is the answer of this expression. The next thing that we are going to read in the topic of the matrices is multiplication of the matrices. So listen now, when two matrices are going to be multiplied, so the columns of first should be equal to rows of second. If this rule holds, then the multiplication is possible, otherwise multiplication will not be possible. So listen again, the columns of the first matrix should be equal to the rows of the second matrix. So look now, here are three matrices given, and it is required to find AB and CB. So look now, first A is written, so solution is here. AB is the requirement. So first A is written, that's why A matrix will be written first. So A 1 3 4 7, and then B matrix is written, so that's why B will be written second, that is 1 0 0 1. Okay, because the columns of the first matrix are equal to the rows of the second, so multiplication is possible. So the method is, first you will take the first row of the first matrix and will multiply with the first column of the second matrix, and then with the second column of the second matrix. Like, look now, so first row of the first matrix is going to be multiplied with the first column of the second matrix. So first element will be multiplied, so 1 into 1. So see this method carefully. Then you will write plus, and then second element will be multiplied, so 3 into 0. Then you will create some space, and now this row will be multiplied with this second column in the same manner. So first element is going to be first element, so 1 is multiplying with 0 plus, then second element with second element, so 3 into 1. So columns are finished in the second matrix. So now second row will be multiplied with first column and then second column in the same manner. So look now, second row is going to be multiplied with the first column. So 4 into 1. So first element is going to be multiplied with the first element. Then second with the second. So 7 into 0. Okay, now second row is going to be multiplied with second column. So 4 into 0. So first element is going to be multiplied with first one. So 4 into 0 plus now second with second. So 7 into 1. Okay, and finally we will simplify the values. 1 into 1. So 1 plus 3. Here you can see 1 into 0 will be 0 plus 3 into 1 will be 3. Here 4 into 1 is 4 and this will factor will become 0. So 4 will be there. And here this factor will become 0. So 7 ones are 7. So the very final step is 1 plus 3 is 4, 3, 4 and 7. So this is the answer. Okay, likewise, the second thing is required, that is CB. So first C is written. So 1, 2, 3, 4, 5, 6. So first C will be written. And then B matrix is written. So B is here, that is 1, 0, 0, 1. So the columns of the first matrix are 3 and the rows of the second matrix are 2. That's why, because this rule is not holding, so that's why not possible. So CB is not possible. Here is a very important question as far as your paper number 2 mathematics is concerned. So O-level class, concentrate. The statement is a bakery produces 4 different types of the breads, namely enriched white bread representing by E, wholemeal bread representing by W, multigrain bread representing by M, and raisin bread representing by R. Delivery is made to 3 distribution outlets. So this is one delivery. So outlet A receives these loaves, outlet B receives these, outlet C receives these, and the cost of the loaf of E, W, M, and R are these one. So these are the matrices given. So look now, this is E loaves, this is W, this is M, and this is R. Okay. From here, the first part is evaluate X and Y. So the first part will be very easy because I have told you the method in the previous question. So you will multiply X with Y. So this is possible because the columns of the first are 4 and the rows of the second are also 4. So these can be multiplied. So you will multiply these two matrices. So you can see here is the answer. So first multiply by yourself and then match the answer from here. So this will be the answer. Okay, in this second part, the thing that is required is, so concentrate, explain clearly what the elements in XY represents. So look now again, here are the elements given. So these are actually the total prices that are obtained from the outlet 1, outlet 2 and outlet 3. So look now, 412 represent the total cost of the breads, that is $412 delivered to outlet A. This is the cost that is from outlet B. So look now, thus the cost of the bread delivered to outlet B is $128, and this is the cost of the outlet C. So look now, and that delivered to outlet C is 166.50. Okay, furthermore, the B part is during a particular month, outlet A receives 25 such deliveries. So listen carefully, and that should be clear in your mind. These are actually the elements of one delivery. So now it is given that outlet A is given 25 such deliveries, outlet B 27 such deliveries, and outlet C 29 such deliveries from two matrices, so that the product of the two matrices will give the total amount collected by the bakery from the three outlets. Find this product. So this is the collection from three outlets for one delivery. So this is one delivery cost of outlet A, this is one delivery cost of outlet B, and this is one delivery cost of outlet C. Now it is given that outlet A is given 25 such deliveries, B is given 27, and C is given 29 such deliveries. So the total cost is required now. So look now, here is the solution of B part. So look now, outlet A is given 25, B is given 27, and C is given 29 such deliveries. And here are the uh, cost of one delivery is given. So 412, 128, and 166.50. So you will multiply one delivery's cost with these deliveries. So same multiplication method will be applied. So because the columns of the first matrices are 3 and the rows of the second are also 3, so you will multiply these two matrices in a normal way. So this is the answer. So this is the answer, which shows actually, look now at the very last line, the total amount collected from the three outlets is this amount. So this is the amount which is collected after all the deliveries which were given in the question.